Jai Janendra, Namaste and welcome to my channel. Today we are going to solve 97th question of the problem solving series and the 7th question of the topic tree. The difficulty level for this question is medium and this question has been asked in Google, Amazon, Microsoft, Meta, Oracle, Flipkart and many other companies. Right view of binary tree. So we are given a binary tree and we need to find its right view. So what is right view? So if someone looks at this tree from the right side, from this side, what will he see? He will be able to see 1. He will be able to see 3, but cannot see 2 because they are at the same level. Okay, 3 will hide 2. He'll be able to see 4, but he won't be able to see 5. So if he sees from the right side, he will just see 1, 3, 4. So we need to return 1, 3, 4 as a vector. In this example, if he sees from right side, you can see that he will be able to see 1, 3 and then 4 and 5. Okay. So right view of a binary tree or left view of a binary tree, the approach would be similar. So if someone had to see the left view, so for left view, the answer would have been 1, 2, 3 here, right? The root will always be seen because at this level only one node is there. And here 2 and 3 can be seen, 3 and 5, 4 won't be seen if you see it from the left. So here in this case, the left view would be 1, 2, 4, 5. We can't see 3, right? Like we can see 3 here, but we can't see 3, right? Here, there are only this 4 and 5, there are no nodes here. So nothing hides this. So 4 and 5 is same for both the right view and the left view. Now how do we solve this? So right view, if you see here, if we see this, okay, so you can think that, okay, if we keep on traveling the right view, if we want to find the right view, if we go here, we traverse this, we get it into our vector, and then instead of, since 3 is there, so we will go, since the right part is there, we will go to the right, okay, and we will traverse this. Otherwise you would have gone to the left, right? Because if the 3 was not there, we would have gone to the left, but here since the right child is there, we'll go to the right and we'll traverse. You can think like this. So you go to the right, you can traverse. Okay, fine. So in that way, and when you see null, you exit, right? So in that way, you could have find this 1, 3, 4. Correct? So which would have been the answer? If you would have done the same thing here, you are in the root 1, now you go to the right, since right child is there, so you get 3. But now you don't have anything, right? So according to that approach, the answer will be 1, 3, because you just want to traverse the right child. And if you think that is the approach, so that solution won't be correct for all the examples, because here after going to the right, we don't have anything, right? If there would have been left, then we could have gone here, because right is not there, but no right, no left, but still we can see this part, okay? So just going to the right for right view, and if it doesn't exist, going to the left view will not solve our problem, because for the other left there could be something which we won't be able to travel here, right? So how do we solve this? So what we will do, you can see here we are concerned with the label, okay? So we have done the label order traversal. So when we go through the label, we see that at each label, okay, if we find the rightmost element, we get it, right? So if you do the label order travel for this 1, then 2, 3, and then 5, 4, okay. Now for every label order traversal, just take the last element. So 1, 3 and 4 will get the answer. So if we do the label order traversal for this one, then 1, 2, 3, 4 and 5, okay. So 1 is in the first level, 2, 3 is in the second level, 4 is in third level, 5 is the fourth level, okay. So now here we take out the last element, only one element. Here we take out the last element 3, here we take out the last element 1 element, so 4 and 5. So we get the answer, right? So this is one approach. We will do the label order traversal, and since we want to find the right view, we will take the last element of the label and we will insert it into the vector and we will get our answer, right? So what would be the time complexity for this? The label order traversal, it will be order of n. But you are taking two extra queues, right, for the label order traversal, and then another vector that we anyway need to take for the answer, right? But two extra queues. So the space complexity is more, okay? So that is one of the brute force approach, but we need to optimize it. We need to reduce the space, right? So instead of we are taking the two extra queues, can we instead of taking that, can we do it in order of one space complexity? Just the vector that we want for the answer, we will just take that vector, right? Say vector is res. Just this vector, no extra q. So how can we do that? So this is one approach. This will work, but there is one better approach. What we can do? So when we are traversing, we will traverse to the right as well as to the left, like we'll do a depth first search. But we will see that, okay, once we have traveled and we have reached a label, so label 0 we have reached, 1 is there. Label 1 we have reached, 1 is there. So if we see that the label in which we insert, since you are doing right view, if we already have an element taken from that, then we are not going to go to the left view and take it, right? So we will compare it with the label, right? So let me code it, then you will understand. What I mean to say, we'll call a function here, recursive function, right view, okay? And we'll pass root, we'll pass 0, and then we'll pass this result, okay? And then after this, we will return the result. So this right view will give us the result, expected vector of result. Okay, so now this void right view will define this function tree node strict root. Okay, and int label. This 0 is the 0th label we are starting with, and this is vector of int, and will pass the address of this vector. Okay, now what we'll do, we'll see first case is if root is null. Okay, if root equal to null, then we return. Okay, we don't have to do anything. This is the base case for most of the problems. Now what we will do, if result dot size is equal to label, right? So in the beginning we see that we are in the 0th label, right? This, if we consider the first label to be the 0th label, okay, and there is no element in this vector, right? So if the number of elements in the vector, we are going to take only one element at each label, right? So if the result, the elements in the vector is equal to the label, then what we will do, we'll insert the value root result dot pushback root value. Okay, we'll insert this value if result sort size equal to label. Otherwise, what we'll do, we'll call this right view and we'll pass to it for this label. First we will pass the right view and then we'll increase the label, right? Label plus 1. Okay, and otherwise, and we'll pass this result, and then we will do it for the left part of the tree also. You'll understand how this code will work. Label plus 1 result, and then this will give us the expected result vector. Now what we have done here, so this is the condition, right? Root equal to null return. Okay, let's dry run this for this example. Second example, so we are here, we got 0, we passed 0 as the label, we pass this root node 1 and this result vector. Okay, now this is not a null, So we will not go into this condition. We will see, okay, what is the size of the result vector now. So result vector size is 0, right? No elements in the result vector. So what will give, and label is also 0. So we'll push back the root value. So we'll push back this 1. Now result has this 1, we have traversed this. Now we'll go here, we'll call this function again and we'll pass the right because we are doing right view. Okay, so the roots right will come. So roots right is 3. Okay, now again when this came, we saw that okay, this 3 is not null. So we will see what is the size. The size of the result vector is 1 and the label has increased by 0 plus 1, 1. So it was 0, now it is 1. So the size of the result and the label is same. So we'll push this value to the vector, right? 3. So 3 has been pushed to the result. Now what we'll do, we'll again call the right of this. So right of this is null, so it would be returned. Null would be returned. Okay, means nothing would be written for this right view. So we'll go to the left of this now. So this left is also null, so nothing would be returned. So now here we went to the right, so we come back. So this right for 3 we have done. Now we will go to the left of this. This left would be called. Okay. So now when left would be called, so 0, in the beginning the label was 0, so the label would be 1. Now we call this left 2 here and we see okay, this is not null, but the size of the result is 2, right? And the label's value is actually 1. 0 plus 1, 1, right? It was done for this. So since this is not equal, we are not going to pass this to the vector, right? So this condition failed. So again we will go to this condition. This doesn't have a right, so this will return null. Okay, but this has a left. So left we will traverse and now label value will increase from 1 plus 1, 2, right? So again since this is not null, so result size is now 2 and the label is also 2. So since these are same, so we will traverse this 4 and same will happen for 5. So in this way we will be able to do a right view of the binary tree. If the question was to find the left view of the binary tree, same we could have done for this label order traversal. Instead of taking the last element, you take the first element of each label. That would be one way. Otherwise, if you want to skip taking cues, you can use this approach where you, instead of calling this right view in root right, we would have called root left first, so that we would have visited this part first. Okay, and then this answer would have come. Just change this root left, this order. Okay, so I hope the explanation is clear. The code is clear, the question is clear. The link to the question is given in the description. Please try it yourself and then come to my code walkthrough section. This is the code walkthrough of the 97th question of the problem solving series and the 7th question of the topic tree, binary tree right side view in the LeetCode platform. You can see the examples that we have already discussed. These are the same examples. You can see the companies that have asked these questions. These are the companies that have asked this question. So let's look at the code. The code is same, whatever we have discussed. Okay, so we'll just run this directly and to verify it's correct, it has been accepted. Okay, you can check the code if you have made some mistake, and I'll submit this now. Okay, so it has been accepted. I hope this question is important and is an important question like all the other comp questions, and you must try the left view of the binary tree. You can search it. Okay, see you also in the next video where I'll be explaining the 98th question of the problem solving series. Jai Jinendra.